All right, hello grade sixes. How are you guys doing today? Hopefully you're ready for some online learning. All right, you can always message me on Teams for any questions. I think this stuff's fairly easy though. I think you should be okay. Hopefully you're staying warm after the storm that we're supposed to be getting tonight. I'm doing this on a Sunday, so we'll see if the storm actually comes. So the lesson today, we're going to look at drawing the graph of a pattern and kind of the process to do a full question, all right? So the first thing we're going to do is there's some different ways to represent a pattern. The first way is to model the pattern with tiles on grid paper. So here, okay, my figure is going up one each time. Okay, so that's the input, let's say in this case, okay, on our input-output table. It goes up one each time, all right? Now the pattern, we have 1, 2, 3 here, and then we have 1, 2, 3, 4, 5 there, and then we have 1, 2, 3, 4, 5, 6, 7 there. So our pattern, okay, is our output here, and it goes up 2 each time. Okay, so if I was to say what would figure 6 be, you would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and you'd add 2 to it, and then you would draw 6, or sorry, not 16, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You draw 13 of these squares, okay? So I'm drawing 3, 6, 9, 12, 13, and this is figure 6, okay? So you could do it that way. You could do it this way as well on a graph. You could go 1, 2, 3, 1, 2, 3, 4, 5, and go all the way to figure 5 here, or you could even do figure 6 or 7. But basically what you need to know is that the pattern is the figure numbers going up 1 each time, and the output or the pattern of tiles, the tiles is going up 2 each time. Okay, the next way you can do it is making a table including a column for ordered pairs. So here it says, this is very, very important. The figure number is the first coordinate, which is x. Okay, the number of tiles in a figure is the second coordinate, which is y. Okay, so we just took our pattern from the last problem there. Our input went up 1, so I counted all the way to 7 here. We went all the way up to 7th figure. Okay, all I did was, I know my pattern goes up 2 each time, so after figure 5, I did 13 and 15. Now what I did was I made ordered pairs. So I looked at the first number here, 1, and then 3, 2, and then 5, okay? 3, and then 7, 4, and then 9, 5, and 11, 6, 13, 7, 15. These are called coordinates, guys, kind of like in our battleship in our last lesson on graphing. Okay, and this is called an ordered pair. An ordered pair is very important when you have a table of values, all right? You need to identify that this first one is always x, and this is going to be y in your ordered pair. Because if you did, let's say the opposite and did 3 and 1, 5 and 2, and so on, then your coordinates and graph would look completely different, okay? Your input would be going up 2 each time, and your output would be going up 1, which is not the correct pattern. So after you've done all that, sorry guys, okay, you can draw a graph. Draw and label a coordinate grid, all right? So we took our table, okay, and we looked at our ordered pairs, and we had 1 and 3, 2 and 5, 3 and 7, 4 and 9, 5 and 11. So I'm going to show you how to plot after, even though you guys already know, but I want to talk about graphing for a second. There are lots of important things with graphing. The first is you need a title. We called it number of tiles in a pattern. Then you have to label your x-axis. So we have figure number, x, okay? And you need to label your y-axis, which is number of tiles. Then it's very important that you add the 0, okay, which shows right here. And now you need to scale. And what I mean by scale is you need to look at your largest number, which is 11 here. So what I can do is count each of these squares as 1, okay? If it was, let's say, 50 as our highest number, I would probably want to say that each square is going to be equal to 5 instead on this part, okay? Because, all right, you want to have an accurate graph, but you also want to have one that you're not going to count all the way to 50 squares because that's super hard on you. So you always want to pick a scale that is going to be good for your graph based on your data that you've collected or the numbers that you've collected. So here it goes up to 11. So what I did was I counted by ones here and ones over here, okay? Now I plotted my points. So I looked at 1 and 3. I went to 1 on the x-axis and 3, and I plotted my point on there. Then I went to 2, and I counted all the way up to 5 on the y-axis and plotted it right there. Then I went to 3, and I found my 7 and went like that. Then I went to 4 and 9. Finally, I went to 5 and 11. If I was to say, what would 6 be? Okay, well, you're going up 2 each time, so it would be 13. Okay, and you're probably going, Mr. S, how'd you figure that out? Well, from the graph, we see that each time the figure number increases by 1, the number of tiles increases by 2. It's kind of like if we had an input-output machine, like I talked about way before then, all right? We have our input goes up 1 and our output goes up 2. So you can find that out with a graph, guys, okay? From 3 to 7 or 1 to 3 or, okay, we go 1 to the right. So let's go instead 1 to 3. We go 1 to the right and then 2 up to get to our next coordinate. We go 1 to the right, 2 up to get to our next coordinate. 1 to the right, 2 up to get to our next coordinate. 1 to the right, 2 up to our next coordinate. So 1 to the right, 2 up to 13. Okay, if I was to say 7, I could know that the coordinates are probably going to be 7 and 15, or I could go 1 to the right, 2 up, and get 15 up here. So make sure that you identify the patterns sometimes because it can make it easier. Okay, the last thing you can do, and it's kind of like the other one, all right, is we can graph the relationship shown in an input-output table. So here, okay, my input's 1 and my output's 5, all right? We can see that our input increases by 1, and here our output increases by 3, okay? So here, guys, if I was to say what is my input-output machine relationship up top, we go up by 3, so it's going to be times 3 plus 2. Okay, well, I've told you in the past that the plus 2 really wouldn't do anything to do with the graphing, right? It would just say where it starts, all right? So we have the input increases by 1 and the output increases by 3. So what that means is we move 1 to the right and 3 up. Okay, so let's try that out. Okay, we start at 1 and we go to 5. Awesome, I plotted that. Now I'm going to go 1 to the right and 3 up all the way to 8. Okay, 1 to the right, 3 up all the way to 11. 1 to the right, 3 up all the way to 14. If I was to say what is 5, okay, I would go 1 to the right and 3 up all the way to 17. So you can really tell a lot by the input-output machine of the pattern. So let's graph this bad boy. 1 second. So let's graph this bad boy, all right? So record each pattern in a table, then draw a graph to represent the pattern, explain how the graph represents the pattern. So you guys have to do this in your assignment today. We're going to do this one together. So the first thing I'm going to do is I have tiles here, okay? Well, I'm going to label them as 1, 2, 3, 4. That's not how many tiles are in them, okay? Actually, it is in this case, but here what I'm saying is figure number, okay? Fig, okay? So here I'm going to go 1, 2, 3, 4. Lovely, all right? So my input goes up 1 each time, okay? All right, now we go to our tiles and we got, oh wow, 1, 2, 3, 4. So here, my tiles on the output went up 1 each time. Plus 1, plus 1, plus 1, okay? Now it says then draw a graph to represent the pattern. Okay, lovely. So the first thing I'm going to do is I'm going to write number of tiles. Sorry guys, it's messy. In a pattern, all right? That's my title. Okay, the next thing I'm going to do is label my x-axis and my y-axis. Then I'm going to write fig number. Okay, that's not a hashtag, that's the number sign, okay? And then number of tiles. All right? Now what I'm going to do is each of these is going to represent 1. So 1, 2, 3, 4. Okay, here's 0. All right, 1, 2, 3, 4. So now I'm going to look at my first ordered pair, which is 1 and 1, and go right here. Then I'm going to look at the next one, which is 2 and 2 there, 3 and 3 there, 4 and 4 there. If I wanted to keep going, I would go 5 and 5 right here. Okay, so we can see that it's going up 1 each time, okay, and to the right each time once. 1, okay, is our input. It's going up 1, and then our output's going up 1. So there we go. 1 to the right, 1 up. 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 Okay, and all of these could be coordinates if I said to keep going. Guys, this is what's called a linear line, which means that the pattern is a linear pattern, all right? You will learn more about that in the future. So that concludes the lesson. If you have any questions, you can message me on Teams. We will have a meeting, but it's mainly going to be for people who have questions. You are expected to do the textbook and the extra practice, and we'll correct as much as we can on Tuesday at our 12:45 meeting for Teams. You guys rock. Keep up the online learning and have a great day.